Hello and welcome into another week of Whether or Not podcast. I'm your host, meteorologist Scott Sumner. We had some severe weather earlier in the week, actually over the weekend, and so I wanted to talk a little bit about wind shear today in the podcast. Now, by definition, wind shear is a change in speed and or direction, either up or down over a short distance. Now, turbulence, a form of wind shear, is present at different altitudes. However, low-level wind shear is the focus of today's podcast and is the most dangerous to pilots during landings and takeoffs. Now, 4 factors that could initiate wind shear are the following here: frontal activity, thunderstorms, temperature inversions, and surface obstructions, i.e. mountains. Now, if a cold front is approaching a runway and is strong enough to create shear, it would have 2 characteristics. First, the front would have a 10-degree or more temperature difference across it, and second, would move at a speed of about 35 miles an hour plus. Now, the presence of wind shear within thunderstorms, however, is one most commonly thought of. Typical afternoon and evening thunderstorms can blossom as high as 50,000 feet. And with the heating of the day, air rises, and as the air cools to a certain point, called the dew point, condensation begins and clouds form. Now, when the water droplets that form the cloud become big enough, they fall, dragging down the air, and that air being dragged down forms what is known as a downburst, as you'll see here coming up in a second by this particular graphic. Now, as a result, a downburst can change wind direction as much as 180 degrees. Further away from the initial downburst of a thunderstorm lies a second problem, that of a gust front, also known as the first gust. Now, as air flows downward from the thunderstorm and slams into the ground, it spreads out, as you see behind me, and can travel for miles at a high rate of speed. This leading edge, I should say, of cooler air forms a miniature cold front. Yeah, exactly, and that could be the problem. Now, the third factor that could initiate wind shear would be temperature inversions. Now, by definition, a temperature inversion supports cold air above warmer air below it, and coupled with strong winds from what is known as the low-level jet stream, that can help to produce significant wind shear close to the ground. So that's another problem there. And lastly, buildings and mountain ranges, as you see behind me here, like the Blue Ridge Mountain Range and the Catoctin Mountains, they can also help to induce and cause localized wind shear by nearby airports. As air flows over a mountain range, it cools and it rises and heats as it falls. This constant temperature fluctuation creates what is called our turbulent eddies. An eddy is defined as a change in the steady flow of a fluid, and in this case, it would be air, causing a vortex or some sort of swirling motion. With the advance of today's technology, terminal Doppler weather radars, called TDWRs, have vastly improved, as you see there, over their predecessors like the WSR-3, which is this model here. Boy, look at that antique, right? And the WSR-57, which is seen here. And now we've had the WSR-88D, standing for Doppler radar system, which is thankfully improved in detecting wind shear within storms, resulting in far fewer incidents and accidents since the middle of the 20th century. The detection and reporting of wind shear related events were poor before the WSR-88D radar was used, as evidenced by some crashes like Delta Flight 191 in Dallas in 1985. But today, pilots are a little bit more learned, and certainly the computer software has improved to the point that if a crash were to occur today, it's usually due to more non-weather related incidences than not. Well, that's all for today. As always, God bless, stay cool, and we'll see you next week.